Okay, we're going to work with some past paper questions on geometry since the session is going to be dealing specifically with geometry. And we start with our first question. So it says in the diagram, EFGH is a rectangle. Very important. We need to know what are the key features of a rectangle. So one of the things that strikes out to us about a rectangle is that all angles would be 90 degrees. We also know that the diagonals of a rectangle are equal. And we know that the rectangle is a parallelogram, which means all the properties of the palm, short for parallelogram, I'm going to say palm in this video, will apply to the rectangle. So very important feature. And it goes on to tell us that M2 is 60 degrees. So we're going to go into the diagram, put 60 degrees inside there. And they tell us that L2 is 40 degrees. So we're going to go to L2, and that is 40 degrees. Our first question here is to find angle F1. So I'm going to change the color because whatever I'm going to do now, which means that we are going to find it, which means we need reasons. So if we go to angle F1, we know the entire angle F has to be 90 degrees. And the reason for that is diagonals of a rectangle. So if we look into this diagram and we want to find F1, so we have lots of options to go the F1 route. So I'm trying to look into the triangle and see what can we use in this rectangle that will help us to find F1. All right, I'm going to allow more people to come in. Anyone got any ideas? Where should we start? Somebody? Anybody? Nobody? I would like this to be a little bit more interactive session. So I'm not going to just be talking to myself here. Okay, let me give you some time to think, and then we can look at it together. Okay, so I'm now going to go for it, all right? So the first thing I would do in this diagram is to find angle M. And angle M would be 120 degrees. And that's because of a straight line. So we're going to say that EMF, to be precise, angle EMF is equal to 120 degrees. And our reason there is angles on a straight line. From there, because this is a rectangle, I know that the diagonals are equal and they also bisect each other, which means that each part here will be equal. Now, if you look at it, we have an isosceles triangle on the top, which I want to highlight for you. So if we have an isosceles triangle, I can now find F1 by stating that angle F1 is equal to 180 degrees, subtract 120, that's subtracting the 120, and we know that F1 and E1 are the same, so we can split that by 2, which means each one gets 30 degrees. And I need a reason for that. And the reason, firstly, I got to state that EM is equal to FM. And the reason why EM is equal to FM, that'll be diagonals of a rectangle. And then I can go on to say that it's equal to 30 degrees because of angles opposite equal sides, which basically I'm trying to say we have an isosceles triangles. So we have our 30 degrees. So we got our F1 to be 30 degrees. The next question is to find GML. So if I want to find GML, let's put a mark on that. GML. And now I'm looking for ideas that's going to help me to find GML. Let me give you some time to think about it. Try it out for yourself before we get into it. Okay, I just want to go over this question again for somebody who joined us a little late. So what we wanted to find here is O1. And we said that O1 is equal to 90 degrees. And the reason is diagonals of a rhombus bisect each other perpendicularly. Then we went on to find L1. So we looked at the triangle KLO, and we use some angles of a triangle. 180 minus 90 minus 34 gives you 56. To find KNM, so we know the opposite angles of a rhombus are equal. So if L1 is 56, L2 will be 56. Diagonals of a rhombus bisect the interior angles. So giving us a total of 112, which is equal to angle N. We go on to the next question. So the question says we have another rhombus here, and they're bisecting at O. ADO is 36.87. It's in the diagram. As you can see, they tell us the DO is 8. And the question here is to find CDO. So before I start, I just want to mark the center angle has to be 90. All angles at the center will be 90. Well, if DO is 8, we also know this is going to be 8. Diagonals of a rhombus bisect each other. So coming to my question, we want to find CDO. So we want to find the angle I'm marking. And that is quite easy. Immediately we can say CDO is 36.87. And the reason is diagonals of a rhombus bisect the interior angles. The next question is to find angle AOD. Well, that's quite easy as well. AOD, we can conclude that AOD is 90 degrees. And the reason for that is diagonals of a rhombus bisect each other perpendicularly. So let me write that down. And we got a 36.87, and we got an AOD, which is equal to 90 degrees. Please write your reasons down. The next one is to calculate the length of AO. So I just want to look at AO. So to get a highlighter out. So if we want to find AO, let's quickly complete the triangle. And if we look at this question, to find AO, we don't know CO, so there's no ways we can find AO using diagonals. And I can try Pythagoras, ADO, but I've only got one side 8, so I can't use Pythagoras. So the next thing I see that is I have an angle in the triangle, and it is a right angle triangle, so I can use some trig concepts. So Tua. Now from the angle of reference, I want to find AO, which is the opposite side. And I'm given 8, which is the adjacent side. So the ratio that has an O and A is 10. So I'm going to say 10 of 36.87 is actually equal to opposite over adjacent. The opposite side is AO. The adjacent side is 8. Now, from there, I can say cross multiply, put that over 1. AO times 1 is AO. And we're going to get 8 times 10, 36.87. So I'm going to give you a chance to type that on a calculator and tell me what you get. If anyone's got an answer for me, please call it out. All right, I think you should be getting 6. So we're going to go to the diagram and we're going to say AO is equal to 6, and we're working with centimeters. Okay, we're moving on. So it says if E is a point, yes.
So I had my hand up, sir. I had a question on
Okay, yes.
8.2, sir.
Mr. Zoom user, identify your name, please, because it doesn't show me who am I talking to.
It's Rhombus, sir.
All right, welcome. What is your question?
Sir, for the one AOD says equal to 90, sir.
Yes.
In my dad, you can say diagonals of a rhombus only, sir.
Yes, we'll accept that for the exam, all right?
No, yes, sir.
Okay. But the proper explanation will be diagonals of a rhombus bisect each other perpendicularly, okay? All right. Oh, sorry, I didn't see your hand up, but now we're ready to roll on. So the next question is quite interesting. If E is a point on AB such that OE is parallel to DA. So they're telling us first, I'm going to now change my color. So we have a point, it says E is a point on AB. So we're going to have E sitting there, but it must be parallel to DA. So we got E. So you can see they're telling us that this line is parallel to that. As soon as you see a parallel line, and they want you to find the length of OE. So I'm looking for OE. So what I want you to be able to construct here is a lovely red triangle. And remember that this is actually the midpoint. In other words, this is equal to this. Whenever you see a midpoint and you're seeing a parallel line, you're going to think about the midpoint theorem. So the actual answer here is, if we're looking for OE, now at this stage, do we know what OE is? Let's quickly put in OA. In the previous question, we found AO, sorry. And if we go to AO, I'm just going to take out the so-called tour now because we finished with it. All right. And then we found AO to be 6. So we know if AO is 6, we know that is 6. So for us to find OE, we firstly got to find AD, because the converse of the midpoint theorem will dictate that OE is half of AD. Now there's no ways we can go find OE at this stage because we don't know what's AD. But if you look closely, the yellow triangle is a right angle triangle, which means I can use Pythagoras. So I'm just going to create some space on my screen here. All right, so we're going to go into the yellow triangle that you see. And then we're going to say, right, AD squared, the angle, the side opposite the right angle is the hypotenuse, so it's going to be AD squared is equal to 8 squared plus 6 squared. And remember, for any exam, you must write a reason. If you don't write a reason, you lose a mark. So you're going to say Pythagoras. And then you can take your calculators out. 8 squared plus 6 squared on a calculator should give you 64 and 36, 100. AD is the square root of 100, giving you a 10. So we got 10 there. Now, to find OE, that'll actually be 5. And what we're using is not the midpoint theorem, it's the converse of the midpoint theorem. So you can put converse midpoint theorem. Okay. All right, that was a good question that we dealt with, as it brought in the rhombus and it merged it with the midpoint theorem. Any questions on this? All right. We ready to go on? Okay, I'm going to give you some time to read, try, and then we will talk about it. All right, I hope you had some time to look at it. So we're going to start from the top. It says the line joining the midpoints of two sides of a triangle is, you must know your statements. If you don't know your statements, in the exam paper, they can ask you to complete the statement like what you see. The line joining the midpoints of two sides of a triangle is, anybody knows? Parallel to the third side and equal to a half the length of the third side. So that is the midpoint theorem. Remember, the line joining the midpoints of two sides of a triangle is parallel to the third side and equal to half the length of the third side. So we're now ready to move on into the question. It says that PQR has E, F, and G. They are the midpoints. So E, F, and G. Now I'm going to quickly mark that. If those are the midpoints, it means that is equal to that. Then they said F is a midpoint. So we're going to say that's 2 and that's 2. That 2 are equal. And then it told us also that G is a midpoint. And let me just put a dot. All right. So we have our midpoint theorem that is there. And then it tells us that G, if we're looking at this now, it's telling us that QG is parallel to FG, which is drawn for us, so it's quite easy to see. But anyway, going to the first question. Question states, prove that EQG HF is a palm. I'm going to highlight that. If you got a highlighter out, let's quickly highlight that. So we're looking for Q, G, H, F. Now, if we look at the diagram, you will immediately notice that we already have one side is parallel, one pair of opposite sides parallel, but that does not make it a parallelogram. For it to be a parallelogram, we have to prove either both pairs of opposite sides parallel, or we could prove that one pair is parallel and equal, therefore it is a palm. So if we're looking at this question, it's quite straightforward. If I look at the question now, I'm going to change my color. I know that FG is also parallel to QF or QR because of the midpoint theorem. So I need to now write that out. For those of you confused, if we look at triangle PQR, E and G are midpoints. If E and G are midpoints in triangle PQR, then it means that EG is parallel to QF, and it also means that EG is half of PR. But the one that I'm going to use to write this out now for you is to say, right, the first thing we know is that, I'm changing my color. We know that QG is parallel to FH, and the reason that was given. Now, we can conclude here that FG is actually parallel to QR, and that is your midpoint theorem. And remember, GH is now parallel to QF because it's the same line. Are you with me? In other words, FGH is a straight line. Okay. And now that we prove GH is parallel to QF, and we know that QG is parallel to FH, I'm just highlighting it that for the reader. Therefore, we can now conclude that QGHF is a parallelogram, and we would need a reason. And the reason is pair of opposite sides are equal and parallel. And that is our 3 marks that we get. Okay. So the next question, it wants you to prove, and I'm going to use the X technique, EG is equal to GH. So if you look at this, we know that GH is X. If we call GH X, QF will be X, opposite sides of a palm are equal. And then FR will also be X because F is the midpoint. Now, if QR is 2X, in other words, this total here is giving us 2X, it means that EG is half of that, giving you the X. And therefore, we can conclude that EG is actually equal to GH. So to write that down could be quite a mission. So let us go and try and write out the solution. And basically, I've used a purple pen. And I'm going to use my X technique because it's much more easier to write out. So where did I start? So I said, right, let us call GH to be X. So therefore, we can now conclude QF is equal to X, and that is because opposite sides of a palm are equal. Remember in the previous question, we proved it's a palm. Now, then we can say that FR is equal to X. And your reason is, well, F is a midpoint, or you could say QF is equal to FR. That was given. So in total, we have QR to be 2X. And therefore, EG now is equal to X. And the reason is midpoint theorem. Now, remember, they wanted us to prove EG. So I'm going to highlight that for you. So EG is 2X. And you've noticed we started off GH, it was also X. So we can now write our conclusion. You can underline it if you want. You don't have to highlight it. Therefore, you can see both are X. Therefore, GH is equal to EG. Okay, the next question there is to prove that ER, and they drew that line, detailed lines, is parallel to PH. So that is quite interesting for us to prove. Let's give you some time to think about it. Okay, I'm hoping you had some time to think about it. Anybody wants to comment before I go on? Anyone has an idea of what we're trying to do here? Nobody? Somebody? All right, so let's highlight ER. Let me use another striking color so that you don't miss it. Let's use, so there's our ER and PH. Now, if we complete the diagram, you'll notice that PG was given to be equal to GR because G was a midpoint. But then we just proved FEG and GH to be both X. So which means EG is now equal to GH. And you can see that the diagonals are bisecting each other. Therefore, it makes that shape a parallelogram. And if it's a parallelogram, it means that the opposite sides will be parallel. So all we have to do now is write that out. So I'm just going to erase my board so we can actually write that out. Okay, so exactly what I've highlighted for you in a diagram, I'm going to now write it out. So we're going to start off by saying that PG is actually equal to GR, and the reason for that it's given. Okay, they told us that G was a midpoint. Now, we just proved that EG is, oh, sorry, that went off my board. We just proved that EG is equal to GH. And the reason was that that'll be proved above, or proved in 322, whichever one you want. So therefore, PHRE is a palm. And the reason why is the diagonals bisect each other. And because it's a palm, therefore we can now conclude that ER is parallel to, let me write that down a little better. ER is parallel to PH because the opposite sides of a palm are parallel. I didn't like that, didn't come out too nice. Let me rewrite that again. Opposite sides of a palm are parallel. And there we have it. Our proof for that question. So let's move on to another question. In this question, give you some time to read it. I'd like to give you some time to read it. So quickly read it and let's see what you can try out. Right, anyone want to share some ideas of what are the possibilities of what we can do? Very quiet class I got today. Nobody's contributing.
So,
Yes.
so what if we say, since they gave us a Rhombus has a perimeter of 12, so we're gonna divide that by 4, so it's gonna give us 3, which means all the sides are 3, so.
But why are you dividing by 4?
Because there's 4 sides. So.
Well done. Yeah, but the 4 sides in a rhombus are equal. All sides are equal. So they gave us 12, and the rhombus has 4 sides. So we're going to say each side in the rhombus is 3. Well done.
Yes, and then PL is good, and LS is going to be half of 3, which is going to be 1,5. So.
Why? Why? You can't just go there. You haven't proved anything.
Oh. Yes, sir.
You have to prove it. It's a 4-mark question. Okay, so you're on the right track. That's a good thing. They tell you that L is a midpoint. So there's your midpoint here. But we can't use the midpoint theorem. We need 2 midpoints. But you know that the diagonals of a rhombus bisect each other. So if we go on the other side, we know that PM has to be equal to MR because the diagonals of a rhombus. Now we have 2 midpoints. So we can now use the midpoint theorem. So we got to write that out, but. So we're going to say PM is equal to MR. And our reason is diagonals of a rhombus. We also know that PL is equal to LS. That was given. Okay. Therefore, you can now conclude that LM is equal to half of SR. In other words, take 3 and divide it by 2, which will give you a 1,5. And right now you can say, right, midpoint theorem. Okay, that will give us our 3 marks.
So,
Yes.
so,
Yes.
I'm confused. So, like, how to use the converse of the midpoint and the midpoint theorem. So.
when you got two midpoints, can you see in this case, we got two midpoints. When you got two midpoints, it's called a midpoint theorem. But if you have a diagram where you only got one midpoint and they tell you that the line is parallel, you see, you don't have two midpoints. This is the converse now. You're using the converse here. That does give you a little more clarity.
Yes, sir.
Sorry, we didn't state in this question, we didn't tell them that SR is 3. So we got to be very careful. Before we start, we should have said SR is equal to 3. And then your reason there would be sides of a rhombus. Okay, we have to say them SR, and you actually can work it out. It's better to work it out. SR is equal to 12 over 4, which is equal to 3, and your reason would be sides of a rhombus. So if I was marking this, I would give this, just to give you a memo marking scheme on this, because it's, so to make SR equal to 3, with the reason will give you 1. Telling me that will give you 2, 3, and I would give you 4 marks there. All right. I want you to read this question, try it out. Let's give you about a couple of minutes to think about it and see what you can do.
Sorry, sir. Yeah, I think you're unmute, sir, because we can't hear you, sir.
All right, can you hear me now?
Yes, sir.
All right, I'm going to start again. Because my sound, my mic was on mute. Okay, so if we look at this question here, they tell us that A and B are midpoints. On P, Q, and QR. So we can see they marked it for us. A and B are midpoints. And it goes on to tell us somewhere in the bottom, WD is equal to DQ, which means that D is a midpoint, and WE is equal to ER, which means that E is a midpoint. So let's start with the big triangle. So if A and B is up two midpoints, that is the midpoint theorem. It basically means AB will be parallel to QR. And if AB was X, it means that QR will be 2X. So that is your midpoint theorem coming out. If we now look at the smaller triangle, the one I'm drawing in green, You can also see that D and E are midpoints there, which means that this line is parallel to QR. But remember, QR is parallel to AB. And if QR is equal to 2x, then DE is equal to x, midpoint theorem. And if you look at the diagram now, you can see AB is parallel to DE, and AB is equal to DE, which actually means it's a palm, a pair of opposite sides equal and parallel. Now, to write it out is a problem. So let's start with, I wouldn't say it's a problem, but it's a challenge. If we look at the big triangle, let's look at a big triangle, all right? So we know that PA is equal to AQ. And we know that PB is equal to BR. And that was given. And also that was given. Therefore, we're now using the midpoint theorem. We can make a statement that AB is parallel to QR. And we're using what we call the midpoint theorem. We can also conclude that AB is equal to half QR. So that's our first part. Then we look at the other triangle, which is the green triangle. And in the green triangle, we can say that, right, they told us that WD was equal to DQ. They told us that WE was equal to ER. And once again, that was given information. And therefore, we can now conclude that DE is parallel to QR. And we can also conclude that DE is equal to half QR. Now, something very important for you to see. So can you see AB is parallel to QR and DE is parallel to QR. So therefore, we can now conclude that AB is parallel to DE. And you can highlight this if you want. You look at AB is half QR, DE is half QR. Therefore, AB is actually equal to DE. So we got AB parallel to DE, AB equal to DE. Our conclusion now has to be, it has to be a palm. Therefore, AD, EB is a palm. And our reason is a pair of opposite sides equal and parallel. Does that make sense to you? All right, we're going to go to the next question. So we're going to read this question. And it says, in a diagram below, okay, let me give you some time, try it out a little before we get into it. The Zoom user is drawing on my diagram. Did you see that? Well done. I'm watching you. All right, let's get into the question. And I want to start off by reading. It tells us that P on the top, it tells you that P is a midpoint of side WQ. And it is marked for us. So let's just put a dot there, showing us that P is a midpoint. It goes on to say V is on WR such that VP is parallel VP is parallel to RQ. So immediately, if you look at this triangle that I'm going to draw in here in blue, the line is parallel, and you're seeing one midpoint, that is the converse. So they want to know, why is WV equal to WR? And your reason will be converse midpoint theorem. And if you're going to say it in words, that's fine. Okay, if you want to say that in words, we can say that a line drawn from the midpoint of one side of a triangle, a line drawn from a midpoint of one side of a triangle parallel to the other side bisects the third side. So can you see that this side will be bisected? Or you could say converse midpoint theorem. Now, the next question is to prove that VWP, and I'm going to now highlight that. VWP is congruent to VRS. So we need 3 reasons. Anybody can come up with 3 reasons why these 2 triangles are congruent? So we'll state in triangle that and triangle that, which is given. I need 3 things to prove that they are congruent. Anybody wants to help me out there? Somebody's writing vertically opposite angles. Well done. Somebody saw vertical opposite angles. Let me mark that. That means V1 is equal to V3. Well done. I'll write that out properly. We can say V1. I can say V1 is equal to V3. Number 2. And that's coming from what we proved, all right? That WV is equal to VR, and the reason here would be proved above. Now my diagram is very clouded, so I just want to erase all this because I can't see the third one, and use a lighter color. Actually, that's black on black. It's not working out. Let's put a yellow. And you'll notice it was given that SV is actually equal to VP. So that's going to be my number 3. So, number 3, I'm going to say that SV is equal to VP, and that was given. And therefore, the two triangles labeled there are congruent, and the case you're looking is side, angle, side. The next question there is to prove that SWPR is a palm, and you can see that the diagonals are bisecting. So it's a very easy one to write out. We're going to write the obvious. SV is equal to VP, and that we said was given. And then we're going to say WV is equal to VR, and that we can say proved above. And therefore, we can conclude that SWPR is a palm. And the reason we're using is that the diagonals bisect each other. We're actually using the converse of that. What the converse means, if the diagonals bisect each other, then it is a palm. So I just want to erase that. A lot happening in this diagram now. Clear it out a little. For the next question. And the next question wants us to prove that PQRS is a palm. Remember in the previous question, we proved that that was equal to that. Okay, let's just mark it like that. And we now know that from the midpoint theorem, that VP, okay, we actually didn't prove that. So we got to now use that fact because we can see it. So I just want to erase this. Okay, so what did we learn in this diagram? If we draw it in PQRS, right, in the previous question, remember we proved that was equal to that. So we can use the midpoint theorem. Just want to create some space now. So we can write. All right, so we're ready to write. And what I'm saying is, if you look at the triangle that I'm actually looking at, so we know, or we proved already, that V and P are midpoints. So we're going to write that out. In other words, VW is equal to VR. That was proved above. Sorry. And we know that WP is equal to PQ that was given. Therefore, we can now conclude that VP, so we got VP is parallel to RQ, and that is the midpoint theorem. Okay, now VP and SP is the same line, so therefore we can conclude that SP is parallel to RQ. In other words, SVP is collinear, or in simple terms, a straight line. That's a very important point for us. So the other thing we want to prove now, you'll notice if VP, as I said, was X, it makes RQ 2X. But VP is equal to SV, so it will make SVX, giving you a total of 2X as well. So all I have to do now is write it out. So we can use the X technique, or we could just say VP is equal to half RQ, and SV is equal to VP, which sounds a little bit more complicated. So I'm going to use the technique called a let. So we say let VP equal to X. Therefore, RQ is equal to 2X. And my reason for that is the midpoint theorem. But SV is equal to VP, which will be equal to X, that was given. And therefore, we can now conclude that SP is equal to 2X. Sorry, not 2Q. So SP is 2X, RQ is 2X. Therefore, RQ is equal to SP. Now, conclusion. You can see RQ is equal to SR. And on the top, we proved them parallel. Therefore, PQRS is a palm. And my reason I'm using is pair of opposite sides equal and parallel. And that completes the proof. Okay, I hope you have some time to digest that before we go on. Just going to clear my screen. All right, going to the next question. It says it is further given that RSTW. Let's highlight the diagram. So they're telling us RST. Okay, that's the palm. Now, what do we know if it's a palm? Let's give, all right, we want to prove that TQ is equal to 3SR. So can you see I blocked out my entire diagram, which is not good. Let's make it with a lighter so we can see that. So I'm going to use a yellow. So TQ is equal to SR. Start with the small side. The small side is SR. So let's call SR to be X and see what happens. Okay, we already used X, used to use another letter. Let's say SR is Y. So if SR is Y, earlier round, we actually proved that PQRS, we proved that PQRS is a palm. So if PQRS is a palm, that means opposite sides are equal, that'll become Y. But WP is equal to PQ. So WP will be Y. But our yellow diagram that we're seeing there, that means SRWT, RSTW was given to be a palm. Now, if that's a palm, it means opposite sides are equal. So it means if this is Y, that's Y, because RSTW is a palm. And if you work it out now, you've got the TQ to be a total of 3y. And SR is y. So therefore, we can conclude that TQ is 3 of SR. If you're going to write that out, I would say, right, let SR equal to y. So therefore, PQ is equal to y. And I'm not going to write the reason, but the reason will be opposite sides of a palm equal. Then you can say WP is equal to y. And your reason there would be given WP equal to PQ. And the last one you would say is TW is equal to y. And that is opposite sides of a palm are equal. So therefore, TQ is equal to 3y. But remember, we started off with SR. SR was y. And therefore, we can now say that TQ is actually equal to 3y. And y is SR. So there we have it. Our final conclusion on that one. Okay, gentlemen, I came to the end of my PowerPoint. And I think we're going to stop, because you are writing a paper tomorrow, so I want you to go and do some preparation as well.